This is the ordinary method of slices. To begin with, you have to do everything to scale. First of all, you have to generate a scale for this question. So this is a known dimension. So I'm going to use this known dimension to develop my scale. So from here to here is 50 meters. So when I measure, I'm getting 4.8 centimeters. So I'm going to say that 4.8 centimeters is equal to 50 meters. Then 1 centimeter, I'll just divide it. I will be getting 3.125 meters. So this is my scale. Now from there, I'm supposed to divide, since this is an ordinary method of slices, I'm supposed to divide this whole failure or this whole slope into slices. So what I'm going to do is, I can just divide this side, right? Then this smaller side too, I'm going to divide this side, right? Then I'll just measure the distance from, so let me extend, so I also have to extend my horizontal line this way. So now from here, let me also do this. From here, I'm going to measure the distance between these two. Then I divide. I want 6 slides or 7. So I'm just going to divide this side and divide by. So let me just measure so that I see. So from here, I have about 8.1. Let me say I have about 8.1 centimeters. So I'll divide by 3, and that will give me 2.7. So I'm going to measure 2.7 here. So 2.7 here, 2.7 here, and automatically this side is 2.7. Then I draw a perpendicular line to pass through here, and the same 2.7 over here. So now I have 1, 2, 3, 4. At this side too, I want 2 slices from here. So I will measure this distance over here. This distance is just giving me, so let me say this is 1, 2. This is approximately 2.6 centimeters. So 2.6 divided by 2, and that will give me 1.3 centimeters. So I'm going to measure 1.3. So this is 1.3. Right. Then I draw a perpendicular line to pass through this way. So now I have 1, 2, 3, 4, 5, 6 slices. The number of slices according to your own preference, right? But the more you divide, the more accurate your work. So this is 6 slices, and I'm going to use that. Now the next thing I'm going to do is you are supposed to draw a perpendicular line, a straight line from the center downwards. So I'm going to just do that accurately. So this is my center. So I'm just going to do this. Right. Now from here, I have to draw a line from the center to touch this side, and that will be my radius, to touch the curve at this point. So now from the origin, which is the center, to this point. So this is my radius R. Right. Now from here, I will have to also get an angle, which is the angle we've always been working with. Now to do that, when I take each slide, I'll have to, so let's see, when I take this 6th slide, I'll have to determine a certain center on the arc around the side. When I determine the center, I'll draw a perpendicular line to pass through the center, and I'll draw a line from the origin to pass through that. So let's just do it. So over here, I have to determine the center of this arc, right? So the center of this arc, I can approximate the center of this arc to lie somewhere around this point. Now, after doing that, I have to draw the perpendicular line to pass through that center. So perpendicular lines, so I'll use short dash lines to do that. Okay, so from there, then I draw a line to pass through the center and that line I've drawn. So I'm going to get something like this. Yes. Then so the angle here, the angle between this perpendicular line and this line is my theta 6. Right. So you are going to do the same thing for each slide. So let's say when I take this slide, which is the 4th slide, I'm going to locate the center. So the 4th slide, the center lies somewhere around the side. So I'll draw a perpendicular line to pass through the center, and I'll then draw a line from this side, right? So the angle over here is going to be my theta 4. Then I'll do same for this one. So the center lies somewhere here, right? I'll draw a perpendicular line to pass through. Then I'll draw a line from here to also pass through this way. Then the small angle over here is my theta 3. Now let me do for this one, so the angle will be somewhere here, right? So I'm going to just do this way. Then from here, so this is the smaller angle. Then I'll do same for this last line. So the center will be somewhere here, this way. Then now I'll draw a line from the origin. So I'm going to measure the angle over here. So this is theta 1, theta 2. This is theta 1, right? From theta 2. Then where is our, okay, this is theta 3. So I think we are left with theta 5. So with this one too, the angle is going to be, the middle of this slide is somewhere around this side. So when I just do this, from here, I'll rule a line to pass through that side. And the angle over here is theta 5. So now I have my 6 angles, 1, 2, 3, 4, 5, 6. Wow. Now the next thing is that, now note that to the left of this vertical line you drew will be negative, and the ones that are to the right of this vertical line you drew will be positive. So now I'm going to measure our angles with our protractor. So starting from theta 1. So I'm just going to measure the angle with protractor. You know how to measure angles. So I'm going to put my protractor on it this way, right? On it this way. Then I read off the value over here. So since I place my protractor on this vertical line, I'm going to retrace this line and read the value. So reading that value, I'm getting 20 degrees. But since it's negative, it's going to be negative 20 degrees. So now, theta 1 is negative 20 degrees. Take note of that. Now we have to find theta 2, just like we measured. So that one too, you measure the angle. So I put this thing over here. Then I read. So I'm getting, from here to, I'm getting 10. So since it's also at the left side, it's going to theta 2 is going to be negative 10 degrees. Now let's measure theta 3. So with that one too, I'm putting this straight edge on this line, right? This way. I think you know how to measure with a protractor. So then I read the value. So that one to 10 degrees. So theta 3 is 10 degrees. But that one is on the right side, so it's positive. Now theta 4. Theta 4 to, so this way, then I read the whole value over here. That's, so this 10, 20, 30. So theta 4 is 30 degrees. Theta 5, and I put it here, the whole value up to this side, and that's about 46. So theta 5, 46 degrees. Then the last one, which is theta 6. So the whole value, trace it this way, so from here, and that's about 63. So theta 6 is also 63 degrees. So I have all my angles. Now I have to draw a table for this. And your table should contain your area, your weight, cos theta, sin theta, Wn cos theta, Wn sin theta. So let's go through how we are going to find that. So now this is area, okay. So you are going to find the area of the slices. When you look at this slide over here, it looks more like a triangle. So you treat this as a triangle. You find the area of a triangle. When you come here, this looks more like a trapezium. This looks more like a trapezium. A trapezium, this shape. So you treat this as a trapezium. When you come over here too, this also looks like a trapezium. So you treat this whole shape as a trapezium. Now this side, you are going to treat this whole thing as a rectangle, right? Then you treat this one also as a trapezium. Then you treat this side as a triangle. So let's start with one. Treating this as a triangle. Triangle is the area of a triangle. That's the half times the base times the height. So half times the base. So I'm going to consider this side as the base and I consider this side as the height. So I'm going to measure the value. So you measure this side, which is giving us 0.6. So the height is giving me 0.6, right? Then I measure the breadth as well. So half time the base, sorry. So this is the base. I have to measure the base. I'm considering this side as my base, and that's giving me 1.3. The base is giving me 1.3. But note that this value, so now you have your base as 1.3 centimeters and your height as 0.6 centimeters. But I realize that this thing is being drawn to scale, so you have to convert it using your scale. So if 1 centimeter is giving you 3.125 meters, then you have to convert this 1.3 and 0.6 also to meters. So you are simply just going to multiply this 1.3 by your 3.125, which you had in the scale. So I just multiply this 1.3 by 3.125. Then I get my base, then I also get my height. Then I find the area of a triangle. So this is it in meters squared. The next thing is for me to find my now the next thing is to find, after finding the area, I have to find the weight. And the weight is simply giving us the volume times the unit weight. And the volume is simply the area times the height times the unit weight. So we are considering per meter, right? So you simply need the area times the unit weight. So we have our area for this one, 3.809 meters squared. And the unit weight for this question is considered as 19 kilonewton per meter cube. So simply multiply 3.809 by 19, then you get 72.371. Then you have to find cos theta. Now, this is the first line, right? So theta 1 was minus 20. So you have to find cos of negative 20, and that gives negative 0.940. And this time around, again, sine of negative 20 gives minus 0.342. Then over here, Wn cos theta n. Your Wn is 72.371. So 72.371 times this will give you this. And the same 72.371 times this will give you this. So that's it for the first one. Now let's take another one, then I will continue filling the table. This is slide 2. So we are considering slide 2 as a trapezium, right? As a trapezium. So you need, with a trapezium, the area is half A plus B H. So your A and your B and your H. So this is my A, this is my B, and this side becomes my H. So I'm going to read off the value of my A. So this is my A. I have about 0.6. Yeah. So my A is 0.6. Then I change it to meters, multiplying by 3.125. Then I get this. When you measure your B, this side is my B. So when I measure, that's 2.6. So I also change again. Then my height is 2.7. The height is just from here to here. So when you measure, that will give you 2.7. Then you convert it for scale. So you simply find the area. And again, the weight is, so you multiply the area times the unit weight, which is 19. So this value by 19 will give you this. Then you need your cos. The angle for 2, we had what? Negative 10. So again, you are going to multiply, you are going to find cos of negative 10, sine of negative 10. Then you must find your W cos. Then you do the same thing over here, right? That's what you are going to do to fill this whole table. Now, from here, you simply have to find the summation of this column. So you're going to add everything in this column, then you sum them up. And that will give you 3141.236. Then you sum everything again in the sine column. Then you get 1958.454. Now, the next thing you are supposed to do, you need your total, you need total length. And yes, you need your total length because your formula, this is a formula work, right? But in your formula, you need total length. So we are going to use that one as well. The formula is simply, so we are finding factor of safety. So the factor of safety is simply the summation of C prime multiplying change in ln plus the summation of Wn cos theta n tan phi all this divided by the summation of Wn sine theta n, right? So meaning that, and you know where you can get your Wn cos theta n. We've already done that in here. Our sine is also here. So we know this value, we know this value. For this question, the phi we are using is 28 degrees. We are using a phi of 28 degrees. And we are using a C of 15 kilopascal. 15 kilopascal. So the only missing parameter in here is our change in theta ln. So we have to find that value. And that value is the length of the arc, the total length of this arc. So this is an arc. So first of all, I have to find, and you know that the length of an arc is given as theta over 360 by 2 pi r. So meaning I need my radius and I need my theta. The radius is simply any distance to the arc. So I'm going to measure any distance to the arc. So let's say from here to here. And the radius is giving me 8.4 centimeters. But I have to convert. So the radius is simply 8.4. Then I multiply by this to change it to meters. So 3.125. And that will give me, so I have 8.4 by 3.125. And that will give me 26.25 meters, right? So I know my radius, I need my theta. So the theta is also simply, so now the theta is also, so I have to also extend this line to touch this arc over here, right? Good. And the theta is going to be the whole of the angle over here. So this to here, the theta is going to be this value. So I'm going to read that value as well. So let's measure. So I put my protractor on it this way, then I read from this value, and that is giving me, my theta is giving me 100. My theta is giving me 100 degrees. Okay, so measure it at your end. My theta is giving me 100 degrees. So now my L is going to be 100 over 360 by 2 pi r, which is 26.25. And my L is simply going to be, so 100, upon this on the calculator, over 360 by 2 pi r, 26.25. And that will give you 45.8149 meters. So I now know my total length as well. So I'm going to substitute everything into this equation. So my factor of safety is simply going to be C prime, which is 15, multiplying my length, which is 45.8149 plus Wn cos theta n. What's that value? 3141.236. So we have 3141.236. Then tan phi. And I told you that our phi is 28 for this question. All divided by Wn sin theta n. And that will give 1958.454. So 1958.454. Then you sum everything, you put all these things into the calculator, and that's giving you 1.203. So your factor of safety for this question is 1.203.